May I begin?
Okay, ladies and gentlemen, welcome to this webinar of the World Bioenergy Association. We will be waiting for a few more moments because we're seeing still a lot of new participants entering the room. So I would like to ask you just for a little patience, one more minute, and then we'll kick it off. Okay, I think it's time to kick off. My name is Christian Rakosch. I'm president of the World Bioenergy Association, and I would like to welcome you all very warmly to this webinar, which will deal with the opportunities to replace coal with bioenergy. We will have distinguished speakers that will give you a clear view on how that is possible. We have two companies that have been very successfully developing coal to biomass conversions, both in Japan and in China. We have a trading house that has a lot of experience in trading biomass, and we have a company that is producing biomass. So we will be able to tell you the whole story in this webinar, from implementation of projects all the way back to the supply chain that is needed to run these projects. But before we go into these technical topics, I would like to hand over shortly to our executive director, Mr. Bharadwaj Kumamuru. He will give you a very short introduction into the World Bioenergy Association, because I think many of you are new with our association, with our webinars. Bharadwaj, over to you.
Thank you, Christian. And just if you can't see me or the presentation, or you can't hear me, just let me know. But otherwise, welcome to all participants from my end as well. As Christian's pointed out, my name is Bharadwaj Kumamuru. I'm the executive director at the World Bioenergy Association. We are happy to host this webinar. And I'll just take a few minutes to briefly explain about WBA, what we do, and the webinars that we've done in the past as well. And if someone wants to be a part of the WBA, we're happy to invite you as well. The World Bioenergy Association, we were set up in 2008 with a mission to promote the sustainable development of bioenergy on a global level. We have a very strong member base of associations, technology companies, equipment manufacturers, biofuel producers, and as you can see on the map, they come from all the countries around the world. And with them, together with our members, we do quite a few activities. We do publications where we focus on the statistics for bioenergy. We've got fact sheets, policy papers, and so on. We also organize events like, of course, the webinar that we are doing right now, but also various conferences and site visits. And we also partner with international organizations, whether it's IRENA, REN Alliance, the UNFCCC, and we participate in various working groups and organize events together with them. More information is available on our homepage, worldbioenergy.org. And just briefly, if some of you have been already joining us in the past, then you would already know the events that we've been doing. But if not, if you're joining us for the first time, just to highlight that we do quite a few webinars on various different topics. Last year in 2021, we focused a lot on the topic of agro residues. We had a case study for Lithuania. We had a couple of webinars on bioenergy and net zero. We also did a webinar on biomethane. This year, this webinar is the third edition, third webinar of this year, where we've already looked at the topic of advanced biomass cooking. We looked at the topic of pellet plants and developing pellet plants in emerging economies. But in the next, after this webinar, we have a couple of other events that we have planned. And if you have any interesting topics that you want to explore, please get in touch with us and let us know. All the webinars, including the presentations, are available on our homepage here. One key event that I wanted to highlight is next month, the 18th to the 23rd of September. We have a very exciting and interesting event upcoming. It's the General Assembly, which includes a various amount of activities. There's 3 days where we've dedicated to site visits, where we visit 1 day with leading manufacturers of cook stoves and pellets in India. There's 1 day we're looking at boilers and briquette manufacturers, and there's another day we're going to look at biogas and cellulosic biofuels. We've split it in 2 locations. One is Aurangabad and the other is in Pune, both in the southern state of Maharashtra. And we're also pleased to organize a conference, the Indian Bioenergy and Climate Change Forum, together with the Confederation of Indian Industries, Aurangabad chapter on the 20th. There's a lot of interesting activities. So if you want to be a part of this in any way, we are pleased to host you. So please get in touch with us. Again, more information is available on our homepage. And how do you get in touch with us? There's 2 ways. One, you can subscribe and follow to get the latest information. So the way you do is you can go to the homepage, worldbioenergy.org, and you scroll to the bottom and you see the link where you can subscribe to the mailing list. But if you want to be more actively engaged, more actively involved, and get all the various benefits of being a member of WBA, then you go to the worldbioenergy.org/join us. And there you can download the form where you can fill out the membership application, and you can send the form to info@worldbioenergy.org to process your membership application. And we'll be very happy to host you as a member at WBA. And finally, again, coming back to the webinar, we're pleased to have you all joining us for this event. And a shout out to Bioenergy International, which is co-organizing this webinar along with us, which is also the official publication of WBA. They're one of the leading English trade publication focusing on bioenergy. Excellent team, excellent content. So if you want more information on them, go to bioenergyinternational.com. And we are happy to, as Christian's pointed out, we've got registrations from more than 70 countries for this webinar. So we're happy to have you all. And to conclude, all the recording of the webinar and the presentations will be available after the event. So thanks again, Christian, and I give the floor back to you.
Thank you very much, Bharadwaj. So we now jump right into the topic. As I said, we will start with 2 companies that have been extremely successful in developing projects that use biomass as a substitute for coal. And the first person I would like to introduce to you is Mr. Yoshinobu Kusano. He is director of biomass fuel department of the Japanese company of Renova. Yoshinobu, the floor is yours.
Thank you. Thank you very much, Christian. Good morning in Europe and good afternoon in Asia. It's a time difference. So can I begin sharing my slides right now? Just a moment. Can you see my slide?
Yes, thank you.
Okay. Hello, my name is Yoshinobu Kusano, speaking from Tokyo, Japan. I am an executive advisor to the company called Renova. Today's subject is biomass as a substitute for coal, opportunity in Asia. Before going to that subject, let me explain how Renova achieved on biomass power generation project. Renova has been developing 7 dedicated biomass power plants all over Japan. 2 of them are in operation, while the rest of 5 are under construction. By the end of 2024, all 7 will be in operation. By that time, total power capacity will be 445 megawatts, purely on biomass. They will need, in total, 2.2 million tons per year of biomass fuel. They are wood pellets, wood chips, and Pks. More than 85% will be imported. Now, I'm going to show you the picture of my power plants one by one. Let's see this right side of the slide, starting from Akita, Kanda, Tokushima, Ishinomaki, Omaezaki, Sendai, and Karatsu. All of them are dedicated biomass power plants, of which size is between 20 megawatts and 75 megawatts, all CFB. This is the picture of Akita. This is the picture of Kanda, 75 megawatts. Tokushima is coming 75 megawatts in next year. Ishinomaki is coming 75 megawatts in 2023, next year. Omaezaki also coming in Shizuoka Prefecture, 75 megawatts next year. Sendai is also coming in 2023, 75 megawatts. And Karatsu, this will come in the end of 2024, 50 megawatts. So all these are Renova's dedicated power plants in Japan. Now, let's go back to the subject. Biomass is a substitute for coal, opportunity in Asia. My conclusion is that opportunity is there. Coal must be replaced as soon as possible. Asia is not only the biomass consuming market, but also the biomass supplying region. My country, Japan, is a good example. First of all, we have a population of 122 million people. This is about 1/3 of Greater Europe. Based on this, we have a potentiality of consuming 10 million tons of biomass per year within 2 to 3 years' time. In fact, the consumption of biomass is rapidly growing. We have two serious issues: decarbonizing power generation to renewable and decarbonizing heavy industry to biomass. Regarding decarbonizing power generation, we have already done introducing biomass fuel to the satisfactory level. Yet, power generation has other options to go for solar PV and wind without consuming to biomass. But decarbonizing heavy industry to biomass, it has just started and need to be focused on because they have no other options than to go for biomass. The heavy industry uses coal as a fuel. They can only go for biomass. If decarbonization is needed, solar, PV, and wind power cannot generate heat. Regarding coal consumption, the steel mill is a big user of coal other than power generation. So similar to Europe, they need biomass, and particularly they need carbonized or torrefied biomass because white pellet or non-treated biomass are too low in calorific value and too soft in some usage, such as a replacement of cokes in blast furnace process. Therefore, torrefied biomass or torrefaction technologies are the must to cope with demand from the heavy industry. Japan is still a heavy user of coal. A revised energy mix announced in 2021 says 19% of power energy source is coal. This is still an ambitious target set by the Japanese government for 2030. We have no declaration of stopping coal usage, while decarbonization declaration by 2050. In order to be a part of the international market, all the industry using coal will make their best effort to reduce coal consumption toward the year 2050. There is an international commitment by the government of 46% reduction of coal consumption by the year 2030. This becomes the immediate and serious target of the heavy coal user. So much so, I can say that heavy industry or general industries are much more serious than power generating sectors in terms of renewable energy introduction. Torrefaction technology on biomass needs to be established as quickly as possible. My understanding is that none of commercial scaled torrefied biomass production facilities are actively running. At least for last 10 years, several torrefaction technologies are tested trial commercial productions, but one of them were successful as far as I heard. Some technology got trial production was okay, but it failed to have the same result on commercial scale. They are not successful in commercial scale production and cost competitiveness, being compared with white pellet or non-treated biomass. Because of this failure, torrefied biomass is not so popular in Europe, if my understanding is correct. However, we are different. We need torrefied biomass much more seriously than Europe. There are two reasons. One, 46% reduction of coal consumption by 2030, which comes within 7 years' time. Number two, no other option than going for biomass. Hydrogen and ammonia, they got a big support from the government, but they are not tomorrow's renewables, but maybe 5 to 7 years later. Japan needs biomass replacing coal tomorrow. Biomass should be an intermediate and ideal solution before hydrogen and ammonia will come. Lastly, I will touch with the subject of, is there biomass available for the volume enough to support both industries, power industry and heavy industry? My answer is yes, but we shouldn't be stick to wood biomass. Agricultural waste, such as flax, straw, sugarcane bagasse, corn stalks, must be considered. Energy crop, such as sorghum, switchgrass, miscanthus, elephant grass, must be considered. Some feedstock has contained the strong chemical, such as sodium and potassium, with high percentage of content. The boiler engineers do not want to use such feedstock as it will damage the boiler. But with some technologies, it will turn out to be a useful biomass in the future. This is end of my presentation. Thank you very much for hearing me. Thank you.
Thank you very much, Mr. Kusano, and thank you also for extending the scope. Usually, we are always talking only about electricity generation, and it's very important to keep in mind that this is not the only place where bioenergy is needed and will be used in the future. At this point, let me say that all of you participants are welcome to ask questions. Please do so by using the chat. So if you have something you want to ask any of our speakers, just put your question into the chat and we will find time to discuss and give you the answers to your question. Our next speaker is Mr. Hong Hao. He is chairman of the company Great Resources, a company that has been extremely successful in China in developing large biomass-fired plants that are supplying heat and electricity, I believe, to various customers, to industries, to industrial parks. Hong Hao, the floor is yours. You're still muted. Hong, you're still muted.
Hello. Yeah. Okay, can you see? Can you hear me?
Yes.
You see my slide? Okay.
Yes.
Thank you very much for giving me the chance to share my experience in biomass energy industry. I have focused in this industry for biomass for more than 17 years. This is my want to share my these 4 parts. I want to share my ideas with you. As you know, China is a number one country to use coal, and it takes 55% of infrastructure of biopower of power stations based on coal. And as a coal power station makes electricity as much as 71%. As our China have our target by end of 2060, we have to reach carbon neutral. So we have to find what industry is the most problem we have to solve. The answer is industry. The industry takes only 1/3 of our total GDP, but it takes 2/3 of energy consumption and also carbon emissions. So we have to focus on.
We only see the first slide still.
Oh, really? Sorry.
Yes.
Why? You can see.
Now we can see the other slides also.
Now you can see my slide?
Yes, yes. We don't see the presentation mode, but it's okay to do.
Okay, I'll just continue. So when we focus on the manufacturing industry in China, we have to find out what kind of our energy users need. That means, do they need more electricity or do they need more heat? The answer is heat. This figure shows that our industries they use 40% of the final energy based on electricity, but 60% based on heat. So the answer is in China, for example, the manufacturing industries, they need more heat energy, not just electricity energy. So we want to find a new, if we want to solve the problem, we have to find the new kind of energy to produce heat, not just to produce electricity. So when we talk about renewable energy to produce heat, biomass is the #1 choice that we can find. So we have a 3 stage to solve this problem. First stage, we need a biomass coal fire to restart coal-fired boilers. Next stage, we need from coal to biomass. The third stage will use biopower plus CCUS. So this is 3 stages. So when we're talking about the biomass, we have to know how many resources we have in China. And this is the figure that we have. That means when we talk about renewable energy, including biomass, or this is hydropower. These two is hydropower. This is nuclear power and wind power. And we can see that biomass resources are #1 compared with other kind of renewables. And this is the map of whole China. We can see when we talk about wind energy, the solar energy, the most located in western side of China, which is only 25% of people live there. But when we talk about the biomass energy, it's in the eastern side, which is 75 people live. That means also the energy users or energy demand located in eastern side of China. So biomass is the energy that we can choose, which compare with our energy consumption, energy need. And this is, and we talk about biomass, and first we think about forest residue, forest biomass resources. This is the map that we can find forest biomass resources in China, and totally we can find as much as more than 8 billion tons of energy. And this map we can find the agri-waste in China, that including some corn, rice, and wheat, any kind of byproducts that we can find from agricultural waste. As much we can find 690 million tons of coal equivalent every year. And we also find some places we can plant energy crops, for example, elephant grass and miscanthus and so on. So in China, we have enough energy, biomass energy resources we can find. When we talk about using the biomass, first we have to analyze labor to check what is inside the biomass. And this is a quality analysis. We set up the #1 that analysis lab in China to check what is inside the biomass, including these parts. And compare with wood-based biomass and agri-based biomass, the difference is alkali incident is quite different. So when we talking about using wood biomass, it will be a little bit easier to instead of coal. But when we're talking about use agricultural waste, we have to do something to change the boiler. This is also another analysis between wood-based and agri-based. This is a picture shows that if you use agri-based biomass, it will be a lot of challenge we have to solve. For example, because the melt temperature of the sludge is quite a bit lower compared with wood-based biomass. And this is a standard we already have in China. And this is the market of whole China. We have more than 650,000 boilers in whole China, including 85% of these boilers coal-fired boiler. Only 1 to 2% of the boiler based on biomass. So we have a lot of potential way to go. And this is the market. For example, the chemical is the #1 industry for energy demand compared with others. So in since China is the biggest factory of the whole world, so we have many kinds of industries. So we have to find the different way to solve their demand of the different kind of industries. But we have to do a lot of job to meet the different industries in China. Not just industries need have energy demand, but also for the urbanization in China is developed very quick. So when a person lived in countryside or living in city, their energy consumption is as much as 4 times different. So since the urbanization in China grows so fast, the energy consumption will be go a little bit faster also. And this is if our final users want, no matter what kind of energy we produce heat, our final users, they want heat. So we compare with a different kind of energy. For example, straw pellets with coal, with wood pellets, with LNG or electricity. So the final, this label shows that our final users, when they got the same amount of heat, how much money they pay. So this is these figures shows these figures. So we got these figures for more than 10 years. And this is a case study. This is the biggest project that we have done by the year 2015. We transfer from the coal boiler into pellets boiler. We use wood pellets, and the boiler, each boiler is as much as 56 megawatt per boilers, and we transfer 5 boilers, 5 coal-fired boiler into wood pellet boiler by the year 2015. This is another case that we produce heat to supply heat to the universities, as much as 1.2 million square meters. This project we finished in 2017. And this is another case that we use planet share pellets to produce steam to supply heat to our customers, which they produce medicines. Sorry, yes. So this is a CHP plant based on coal straw, because this CHP plant places in the coal planted areas. So we can find this is a corn straw, and we supply corn straw to supply our CHP plant. This plant as much as 30 megawatt produce electricity, and 3 times of they produce heat also, and produce steam, and supply heat to more than 2 million square meters buildings. And this is another case that we use wood chip and cotton straw to produce steam to our customers, and reach low emissions. And this is another case that we use a briquette of corn straw to produce heat, air, to dryer the corn. So right now we have 3 projects that to set up a carbon neutral town, carbon neutral industry zone, and carbon neutral city. So we can supply our customers from service, from planning to construction, and to running our infrastructure to our customers, to help our customers to reach carbon neutral. So this is my presentation. Thank you very much.
Thank you so much, Kelvin. That was extremely interesting and also very important that you're highlighting the role of heat, which seems to be much larger than actually the role of electricity. And I could add that in Europe, it's no different. People usually confuse energy with electricity. Also policymakers do that usually. But very often it's not about electricity, it is about heat, and biomass is very well suited to supply heat. And I should add, in Europe, the by far largest part of biomass that is being used for energy is being used to generate heat at all kinds of different scales. So thank you very much for that contribution. Please unshare your slides now. Let me shortly look at the I'm sorry. Let me shortly look at the questions that have been coming up. There was questions regarding the torrefaction process. That is something that maybe can be supplied. Here is a question to Mr. Cusano. What about the energy needed for collecting and transporting biomass before processing? How large is the share of energy that you have to invest to finally get the fuel to your power plants? Can you comment on this question?
Yeah, thank you very much for the questions. Now, exactly that point is very important for me as well, because I don't like to spend a lot of energy and a lot of cost for collecting feedstock and making a biomass and transportations. So all the calculation is carefully assessed before I will go ahead to take any feedstock as a biomass. So I can't show anybody exact figure because this is a business secret, but I can say that I can carefully assess those figures for before I would determine to buy the subject, by the biomass. Thank you very much.
Let me add to this. Thank you for your comment. In Europe, new industrial users of biomass must comply with the requirement to reduce CO2 emissions by 80%. So they are not, the entire supply chain of biomass must not consume more than 20% of, or produce more than 20% of the CO2 that is prevented from being emitted. So in fact, using biomass is very effective in terms of energy balance of supply. So let me see if there is another interesting question that maybe can be handled in this discussion. So let me see. Later on, I think we'll carry on with the presentations, and I'm very glad to introduce our next speaker to you, and this is Mrs. Hinako Yoshida. Mrs. Hinako Yoshida is from a trading house from the company Hanwha in Japan that is trading with biomass, and trade is a very important piece of the puzzle. You need to have a supply chain, and we're right now going back from the use to the supply chain, and then finally to the producing of biomass. And I would like to hand over the floor now to Mrs. Yoshida. Please go ahead.
Hi, can you hear my voice?
Yes.
Yeah, thank you. Okay, so good morning to European people, and good afternoon to Asian people. Hi, I'm Hinako Yoshida. I work for Hanwha Energy Department. And then I've been in Hanwha for 3 years, and I'm basically in charge for sales, but I also do, but I'm also in charge for the sustainability side as well. So I'm gonna go ahead and start my presentation. Okay, so this is just a basic company profile. So for my team, we belong to the energy section, but for as a Hanwha as a whole, we do steel, we do non-ferrous metal, we do chemicals, seafood, cement. So we do quite a lot of product actually. And then for within our team, what we trade is basically we do mainly Pks, which stands for palm kernel shell, and we also do wood pellets. And as Mr. Kusano has introduced, in future-wise, we would like to also trade a black pellet as well. And I would also like to introduce our team structure. So in Japan, oh, I don't know why the number is gone, but we have 10 members within Japan. And in Japan side, we are in charge for selling to Japanese companies and also a total manager of this team. And we also have quite a few other members in Southeast Asia, mainly in Thailand, Indonesia, and Vietnam, and they are sourcing side for the Pks and wood pellet. And I would also like to introduce our strength. So we think that when we supply the biomass energy, we think this stable procurement is very important. So that's why in Yamaguchi, Tokuyama, we have a domestic stockpile, which can hold for about 100,000 tons. And what we do is that when the customer needs Pks in emergency, we will supply in local domestic vessel, which can load about Pks for 1,300 metric tons. And also number two, when it's biomass, we also think for the power plant, the quality management is important as well. So every shipment we do, we have like a line group where our inspector team goes to the actual loading site and reports us 24/7. So here is our Pks work record. As you may all know, so the FIT power plants is increasing year by year. So that's why the whole Japanese demand is actually going up all the way to around 5 million tons per year. And that'll stay stable from 2023. And within the whole demand, Hanwha, we do around just about less than 30% of the share. So currently we are a #1 Pks trader as of right now. And for wood pellet, that is also going to increase as well. And by the end of fiscal year 2025, we think the demand will go all the way up to more than 9 million tons. And as the demand grows, our share is also increasing as well. And as for number 3, strengths, we think this securing the transportation is also important when we want to do the stable procurement. So in 2019, we launched our own vessel called Midori, which means green in Japanese. So currently we have this one vessel that is dedicated to Pks and wood pellets. And this is for customer side, but since we are trading quite a lot of amount, we are flexible when it comes to delivering. So sometimes we do one discharge in first port, and then we do a second port discharging as well. And this is another Hanwha's wood pellet trading record as well. So our amount of the trade of wood pellet will grow as the Japanese demand grow as well. And as you can see in the chart, the wood pellet trading demand is actually gonna grow annually by 75%, which is a rapid increase compared to PKS. Because that is because the wood pellet is a lot of times supplied for more of the bigger power plants. And when it comes to the storing wood pellets, we think since Japan is such a small country, we need to be flexible in terms of the storing as well. And also when building such a big stores in Japan, it costs a lot of money. And as Hanwha is actually, Hanwha's main products is actually a steel, we come out with a special container where you can use the container as a transferring, but also using container as a storage as well. And this is just like a specification of the special container. As you can see, the discharging is only from here, so it is a lot more safer compared to the ordinary container. So going back to the main topic, the Japanese coal replacement to biomass. As you can see from the chart, Japan is actually one of the largest coal consumption countries. And here are some of the biggest sectors in Japan who consumes coal. And for energy sector, a lot of Japanese companies are trying to use hydrogen or ammonia in order to achieve carbon neutral. And that also goes same for the steel sector as well. And for the cement, they're trying to use the carbon capture. And for the food industry, they're trying to use ammonia. And for the chemical industry, they're trying to use hydrogen in order to achieve carbon neutral. But once again, hydrogen and ammonia will take somewhat money, and also it consumes a lot of time. So we believe the black pellet or the torrefied pellet or carbonized pellet can be a filler to achieve carbon neutral. So exactly what kind of sectors can apply torrefied pellets or the carbonized pellets? So we think these two are I would say, easiest and fastest sector that can use black pellets. So for the power generation, the first category is for the FIT. Some of you may know that for a Japanese biomass power plant, they use FIT system. And for the FIT system, they're given certain amount of percentage they can use FIT. But then when using only white wood pellet, they can only maximize certain amount of percentage. Let's say one power plant can have the maximum of FIT percentage 40%. But when using only PKS and wood pellets, they can only achieve around 35% or maybe 30% perhaps. So one of the solutions to maximize FIT percentage is using black pellet, which has same amount of calorific value close to the coal. Other sector we can use is for non-FIT. So that'll be just simple replacement of the coal. And also one of the biggest sector is for the chemical industry or industry sector. They would need to use biomass or black pellet for the CSR because they're so close to the end user. They would need to promote that they are creating products from the green energy. And also the other sector we have is the steel sector. The steel sector would obviously need to provide green steel because a lot of steels they are contribute to the cars, and cars are used for the end users, which the end users they are starting to prefer more greener cars. And also for Japanese company, if they want to sell the steels to the European side, they would still need to pay carbon tax anyway if they don't achieve the certain amount of GHG emissions. So in summary, I or Hanwha, we think the black pellet is necessary for not only Japan, but for Asia as a whole. But the issue we have right now is that not many suppliers can supply big amount of black pellet. So we would still need to keep thinking, how can we solve the demand for the black pellet? And that'll be all for my presentation. Thank you very much.
Thank you so much, Mrs. Yoshida. That was a very good insight in how a trading house works and how you are handling the growing demand of biomass. There have been two interesting questions I would like to pose forward to you. One was, what about the recent sustainability regulations regarding PKS and also wood pellet imports? How does that affect your operation? And another question was, how do you secure as a trading company pellet quality while you are managing the product through the supply chain?
So sustainability side, we think it's not just about the supplier side. We also think it's important for the end user or the trading side as well. So that's why actually Hanwha, I think 2 years ago, we hosted like a Pks sustainability webinar where we told Japanese customers that we need to raise awareness for the certification. And since then, I think Japanese biomass market has boosted the increased awareness of Pks certification. And as you may know, actually Japanese FIT, you would need to achieve GGL, RSBO or RSB or ISCC in order to get the FIT subsidy.
So you need to have the certification for the sustainability of your supply chain, of your biomass.
Yeah, you would need to supply like the certified cargo for the Pks as well. And that's also same for the pellets as well.
Okay, but that is fairly new, isn't it?
Yeah, I think, I mean, I guess this is like recent movement. People's awareness toward the certificate sustainability is raising. So I guess, I mean, when using biomass, I mean, biomass needs to be sustainable. So I think it's important that we care about the sustainability side, using certification as third person opinion, not opinion, but third party scheme is important.
So an independent checkup whether
Yeah.
the sustainability is actually achieved. I
Yes.
completely agree with you that this is fundamental to the future of our industry. If we cannot prove that the biomass that you're using is sustainable, the whole exercise doesn't make any sense. So this is really critical. Thank you very much. Thank you very much. And we'll carry on with our next speaker, which is Mr. Kenneth Tran. And Kenneth is producing pellets in Vietnam. And I think, Kenneth, you will also give us an insight on how you see the issue of sustainability as a pellet producer. The floor is yours.
Thank you very much for the introduction, Christian. Let me share my screen. Here. All right. And give me a thumbs up if you see my screen all right.
Screen is fine.
Okay. So thank you for having me here. And I'm glad to speak in this webinar from the producers of biomass fuel perspective. And this is the outline of my presentation today. First, some introduction about our company. And then I will switch gears to focus more on the challenge to the sustainability problem of biomass. And then talk about the potential, the opportunities for biomass energy in Asia, as well as the potential for Vietnam as a leading country for the production of biomass fuel, and then I will share some additional references to you as well. So let's move on to the introduction about the company. We are one of the many wood pellet producers in Vietnam. We tend to focus on quality and sustainability. As of today, we have facilities with the capacity of 125,000 metric tons a year and fully contracted already. So if you think in terms of energy content, that would translate to about more than 2 billion gigatons of energy. We strongly believe in the robust long-term demand of biomass energy globally as well, and especially in Asia. And I will talk about that, the growing demand in Asia in general and the underlying reasons why it is the case and why Asia can even leapfrog Europe in terms of biomass energy demand. As of today, we are building new production facilities to meet the growing demand. As I mentioned, as a company, we focus on delivering high quality, sustainable, meeting the criteria in Japan and also in Europe as well. Here are a few sample pictures of our facilities. This is our wood material yard. This is the wood pelletization machines, highly automated with the control room here, centralized control room, and this is our warehouse for storing the wood pellets ready for delivery or for export. There are a couple of articles about us on biomassmagazine.com in case you are interested in knowing more about the company. With that quick introduction about the company, let me switch gear to the technical topics about the challenge to sustainable biomass. The main thesis for biomass energy as a substitute for coal is that it is renewable and sustainable. And the main reason for the sustainability and carbon neutrality of biomass is that biomass, so when you burn wood pellets or when you burn biomass, it does release CO2 to the atmosphere. So the energy itself is not carbon neutral, but the carbon it released, the thesis is the carbon it released to the atmosphere should equal or is less than the carbon that the forest and the trees absorb. So because of that complex sustainability thesis, and so the biomass energy by itself is not considered renewable or sustainable. So it requires the complex management of the supply chain and the carbon accounting to make it sustainable. So the supply chain may make some biomass energy sustainable and some not so much. So whether it can substitute coal effectively or not, we need to look at the whole supply chain. A little bit more technical so I would like to make this argument that in our opinion, there are 3 layers of challenge for the sustainability of biomass energy. Number 1 is what I call the green growth challenge. So if you look back to the underlying thesis of biomass energy, then we will need to ask the question: can we ensure that the new trees that we try to grow for biomass energy, can we ensure that they grow faster than the consumption of wood or agricultural waste for making the pellets? The second challenge is the ecosystem. In the countries that, let's say, in the region that produce biomass, does it have a healthy and in this presentation, because we produce wood pellets, so my presentation is going to be woody biomass centric. So the question here is, does the supply base have a healthy wood ecosystem? For example, does it have a healthy lumber industry? Does it have a healthy furniture industry? To ensure that the trees that we grow, and not just for burning, it should, like most of the trees, or like the majority of the trees, should be used to make wooden products that can capture the carbon. The third challenge that a lot of countries are facing and producers are facing is the certification and the notion of carbon accounting. And carbon accounting by itself is a very complex topic. So the questions are, are there certification programs to ensure that the wood pellets are made from true residues and not from the whole trees or illegal harvesting? Is the carbon assumption sequestration during the supply chain of wood pellets being accounted in the right way? So that's the whole topic of carbon accounting. So so in this short presentation, I would like to argue that among those three challenges, challenge number one and number two are very hard to solve with just mere policies or management. The challenge number three is probably the easiest to accomplish, and then followed by number two and number one. With the challenge number one, you have to rely completely on the climate and the geography of your region, and that is not something that that the governments can do anything. So with that in mind, I would like to move on to the argument for Vietnam as a leading country for sustainable biomass fuel production. For the following reasons, Vietnam has the optimal weather conditions for the tree growth. It is a tropical country with a lot of solar radiation. And for those who in forestry or grow trees or plants in general, we know that light and solar radiation is important for tree growth. High humidity is also important for rapid tree growth. And so Vietnam has those climate advantages. And to be more specific, there are some species such as acacia and eucalyptus. They grow in Vietnam. So this is sort of similar in other countries that are near the equator in Central America as well. But it's not true for northern countries like Canada, US, or in Europe. Just for some statistics, according to the old data 10 years ago, and Vietnam forest management was not that good even 10 years ago. And Vietnam forest growth rate is already more than twice the rate of forest growth in the US South, which is the leading hub for biomass production as of today. So the second advantage that Vietnam has is the wood the wood-based economy, what I call the ecosystem. Vietnam currently has a vibrant market for forestry products. It is one of the global furniture manufacturing hubs in the world. So we can think of all the countries that have the climate similar to Vietnam. Only Vietnam has the furniture manufacturing advantage to ensure that most of the trees will be used for manufacturing, for lumber products. It's also the world's largest wood chip exporter. So Vietnam has a very healthy and vibrant wood-based ecosystem. The number 3 advantage is the labor advantage. It has a young, hardworking, and inexpensive workforce. And this is an image that shows that. So there are several farmers. So a lot of forests in Vietnam are owned by the smallholders, and they are poor farmers, and they find creative ways to harvest the trees at very low cost. In other more developed countries, it will take longer time just to figure out how to harvest trees on the hillsides and how to use mechanization, and it's very cumbersome in general. And this image shows that even though when you look at the map of Vietnam, you see a lot of nice beaches and the coastlines, but to the western side of Vietnam, it's actually widely covered by plantation forests. And as I mentioned, they are primarily owned and grown by the smallholders. So in terms of so Vietnam currently lacks the robust certification system, and that is to be improved. By recognizing this issue, the government has worked with the PEFC to create a new Vietnam Forest Certification System called VFCS to rectify that problem, and it is working very well. So perhaps I would like to stop my presentation here and welcome questions from the audience. Thank you very much. And I have more reference in case someone wants to read technical publications later.
Thank you very much, Kenneth. That was very impressive and very interesting. One question that occurred to me immediately when I saw your pictures was, in that picture of the harvested site, it looks like the trees were even debarked on the site, correct?
That is correct by the farmers, and they have a very manual but very highly efficient way of debarking small trees. Yeah.
And is that in order to increase the quality of the pellets?
So those trees are primarily harvested for making wood chips for the pulp industry. But the same kinds of trees, and for example, the smaller parts of the trees can and should be used for making wood pellets.
I mean, the downside of debarking in the forest is that usually then you cannot use the bark as a source of energy.
You can mix a small percentage of bark, but you have to control it. It's all about the control of your mixing ratio. So that's an art in biomass fuel production.
Right.
But, so at our factory, we usually debark and then use the bark for the burner, for the drying system, but not for making wood. Yeah.
Right. That is very sensible, because then you are using actually renewable energy and you're bringing down your CO2 emissions in the context of production. That's how it's done in many places, to use the bark as a fuel.
Yeah.
That is why I was asking the question. Fine. Thank you very much, Kenneth. I think there were a couple of questions showing up that I didn't notice yet, and I would like to jump back a little bit to also ask a question to Hong Hao. And that question relates to a picture also that you showed, which addressed the technical problems of dealing with biomass that is coming from agricultural residues. You mentioned that they have very elevated levels of alkaline, of chlorine. They are very corrosive. You're running these plants. How are you managing the technical issues? Is it possible to use these fuels even though they have very difficult combustion properties? Kelvin, you're muted. You're muted. now.
Okay, thank you for your questions. First, I would like to say you have a different design with coal-fired boilers. It's very popular in China. We have a phase that they only use coal-fired boilers directly to fire the biomass. That will cause a lot of problems. So first thing, you have to have a new design based on what kind of biomass you use. And when you choose wood pellets or wood-based biomass, that will be easier. But if you choose, for example, corn straw, rice husks, and wheat straw like this, you planted it in different area, the element will be different. So you have to be sure what kind of resource and what kind of analysis about the element, what kind of biomass you use. And then based on this, then you can begin to design your boiler. First important thing, you have to keep a low temperature of the fire, because generally, if you use agricultural waste, the temperature, the temperature of the boiler is a very important thing. They don't need so high temperature of the inside the boiler. They don't need high temperature. So you have to keep a low temperature compared with the coal-fired boiler if you use biomass resources. The second thing is sludge. And even though element, for example, K, so you have to produce with these kind of emission of these alkali elements. So the ash is very important thing. So the transfer of the heat have to be a different design, quite different with the coal-fired boiler, because it will be produced a lot of ash if you're based on agricultural waste. So this is the third important. The fourth important thing is when you use after fire. I see some the ash. What can you use about this ash? Generally, it depends on how many styles of agricultural waste you use. For example, if you use only one style, then it could be used as fertilizer, because that quality is stable. The element inside is stable. If you different kind of agricultural waste, then it's quite difficult to use as fertilizers. It only could use as cement or other kind of things. So it's the one important thing is the resources, the biomass resources. So you have to got very clear analysis about the resources. Then based on this, then you got the right the design of your boiler. Understanding about this. Thank you.
Thank you very much. I totally agree with what you're saying. Just a little bit add-on question. In Europe, we see that the most advanced combustion systems that we have right now are not burning the biomass, but they're gasifying the biomass, and then they are burning the gas, which means that they have a low temperature in the gasification zone, and they have hardly any ash in the flue gas, which brings down the contamination of the heat exchangers. Is that something that is also considered in China?
Yes, we also, it's very popular in China, but only small size boiler, which means small size will be lower than 40 tons, because you cannot got high capacity of boilers based on gasification, because it's we cannot got enough technology to support this. But if small size, for example, is lower than 40 megawatt, like that, it's quite easy to use the gasification technologies in China. It's, and it will be easy to clean the fires, the ash, and so on.
Right, right. Thank you. There was another interesting question to Mrs. Yoshida. There was a lot of talking about the black pellets, and there was a question of a participant asking, would Hanwha consider to invest in third-party ventures to produce black pellets? So are you considering to also go upstream and support upstream development through investment? Is that something that Hanwha has been considering in the past?
We haven't made any decision whether we want to invest to the upper stream for the black pellet plants, but yes, definitely investment is within our mind, because I mean, we think it's, as a trader, we think it's very important to secure the cargo by investing to the plant.
That's interesting to hear, and I'm aware of other players that are also integrating towards upstream, because it gives much more safety in terms of supply chains, and also very often the investment is an issue that is not easily handled by small entrepreneurs, and they need partners who have the capacity to do so. And one more question to Mr. Cusano. Are you still there?
Yes, of course.
Excellent. The question was whether you are only generating electricity, or are you also considering, or you have opportunities to use the heat that is produced in your plants?
My answer is only Renova generate the power, no heat at this moment.
And do you believe that this is going to change in the future, that you will also have projects where you can use the heat?
Well, I think it is not easy to consider, even in the future, to have a joint, the power and, steam, heat making, because not like Europe, Japan does not have such infrastructure to deliver the heat or steam to the areas. So, for example, for winter season heat, probably many households just use electricity to heat the house. So I don't think it is not like Europe. Japan is still focusing on the electricity generating as far as the power generation is considered.
And
But
sorry?
No, go ahead.
What about industrial heat demand, like the projects that Hong Hao has introduced? Many of them are industrial heat demand. Is that an option that you have looked at?
Yes, that is what I'm seeing these days, because industrial people need heat, of course, and like they are using a fossil fuel of coal for their the raw materials as well. So they can't be replaced by solar PV or wind. Only biomass is the option for them to go. So because of that, the general industry needs a heat. Heat demand is there.
Right. Thank you very much. I think with this, we are slowly coming to an end of our session. Let me just look on the last questions here. Yes, there is one interesting issue for Kenneth still to discuss, and that is, how do you see the competition for fiber between pulp production and energy production, in pellet production? You mentioned that the trees that we're sawing, the deep bark trees that were going to chips, which were going to pulp production. How is the situation? How is the balance in Vietnam? And how is it going to change maybe in the future? Will the pulp industry take over most of the raw materials? Are you worried about this, or it's going to be the other way around? How do you see that?
Thank you for the question. I think that in the long term, there will be more wood chips factories located along the coast because of the transportation logistics with carrying wood chips. So the woods that are used for making wood chips cannot be far away from the port. So I foresee that in the future, more wood pellet producers will move towards the western side and further away from the port. And then because carrying wood pellets is much more efficient than carrying wood chips. So that's one way of separating the two. Another is leveraging the residues from the trees, for example, the top and the branches of the trees that are not suitable for making wood chips, because wood chips production requires the logs to be fully debarked at the forest, as you saw in the pictures, and wood chips producers require the logs to have the diameter above 6 centimeters or so. So the remaining is the true forest residues, and the forest residues are suitable for making wood pellets. So there are two sources for making wood pellets: the smaller parts of the trees, as well as the trees that are located far away from the coast.
Excellent. That's a very interesting explanation, and it shows that there may be even not only competition but also synergies between production of chips for the pulp industry and pellet production. Right.
And I also would like to bring another ESG factor here. Today in Vietnam, if you go to the western side, to the mountainous side, there are very poor farmers who still grow agricultural products. But the wood pellet industry, because of the densifications of the wood pellets, that enable longer distance transportation. So this will create a new forest-based economy for the farmers in the wetland. Right,
right. And would that be in competition then with food production or not?
Not so much. So in the wetlands today, they grow sugar canes, and they grow. There's no centralized and large-scale economy, and so they grow coffee, nuts, sugar canes. So if growing forest creates better income for the farmer, they will switch.
Right, right. Thank you very much. I would like to thank all of our presenters. I think it was a very interesting and also practical insight into what bioenergy can do, what kind of plants have been already established, what kind of supply chains are in the building and growing rapidly, as you have seen in the view graphs. I would like to thank all of the participants very much for staying with us. And I look forward to announce the next WBA webinar. Please have a look on our website. There have been questions regarding the recording of this webinar. It will be available on our website within the next few days. So please just look at worldbioenergy.org and you will find the recordings of this website. Thank you all for being here. Have a nice day. Goodbye.